Okay, this lesson is on solving linear inequalities. But before we can actually solve some inequalities, we need to talk about the notation that we have here. Let's take, for example, x greater than negative 2. That's an inequality. On a number line, we would find negative 2 here. And all our x's are supposed to be greater than negative 2, so I would shade, as best I can here, blue, everything greater than negative 2. Now, are we including negative 2? The answer is no, we're not. We're strictly greater than negative 2. And so we would put an open circle here. Or, I believe that the way that some books do this is instead of an open circle, they would put a parenthesis like that. They mean exactly the same thing. You can use either one, open circle or parenthesis. Interval notation. If you look here, we are starting at negative 2, and we're going out to the right toward infinity. Keeps going. The infinity symbol is just like a sideways 8 there. Now, we are not including negative 2, so we want a parenthesis here. So whatever you have here is going to be the same as there. And you can never really get to infinity, so you always put parentheses next to an infinity. You never have a bracket, as we'll see later. And so this is called interval notation. And here it is graphed, and this is our inequality. These are three different ways to represent the same thing. Here's another example. X less than or equal to 1. So I'm going to shade everything below 1, just like that. Now here we are including the 1, so we want either a closed circle here or I believe as your book would do it, instead of a closed circle, they would put a bracket there. A bracket is the same as a closed circle. So either one of those is acceptable as the graph. Interval notation. Well, over on this end, we're at negative infinity. Very large negative numbers. And then we go up to 1. Since we are including 1, we put a bracket here. If we were not including 1, we would put a parenthesis. And negative infinity, remember you can never actually get there, so you always put a parenthesis next to an infinity symbol. Make sure that this is the left side and this is the right side. So it would be wrong to write it this way. You don't want it backwards. That would be incorrect. You always want the larger number on the right side over here. Here's another one. X is between 0 and 3. 0, here's 3. X is greater than 0 and less than or equal to 3 at the same time. This just tells us to shade in between the two numbers 0 and 3 like that. Now, are we including 0? The answer is no, we're not. X is strictly greater than 0, so I'm going to either put an open circle here or a parenthesis. I'll use parentheses and brackets now. Over here, the 3, are we including 3? Yes, we are. It says less than or equal to 3, so I put a bracket to include it. And so this is what that inequality looks like graphed. Interval notation, well, we're going from 0 to 3. We are not including the 0, and so there's a parenthesis. We are including the 3, and so we put a bracket. There it is. Just a couple more examples of this. Let's look at x less than -1. On a number line, we would shade below -1, like that. We are not including -1, it's x strictly less than, so we want a parenthesis like that, or an open circle. And in interval notation, this would be -∞ up to -1, parenthesis here, and parenthesis there. So once again, we have the inequality form, we have the graph form, and we have the interval notation. And last one of these. X is between -2 and 1. That tells me to shade between -2 and 1. Just like that. Are we including -2? Yes, we are, because of this equality symbol here. So I'm going to put a bracket there. And we are also including 1 because of that equality. And so we want a bracket there as well. And so in interval notation, this would be bracket, -2 to 1, bracket. I guess I should include one more here. Let's throw in one more. X is between 1 and 2. Shade between 1 and 2. Just like that. We are not including 1 and we're not including 2. Strictly greater than 1 and strictly less than 2. And so I want parentheses on the 1 and the 2 here. We're going from 1 to 2, not including 1 and not including 2, so we want parentheses like that. And that's what it looks like in in interval notation. Be careful, this does not mean the point 1, 2 that you plot on an x, y graph. This actually represents the interval from 1 to 2 on a number line. Okay, next. Let's solve a linear equation here. X minus 7 is less than -12. Now we solve inequalities just like we solve equations. All the same rules apply. However, there is one extra rule, and that is when we have to either multiply or divide by a negative number on both sides of the inequality, we have to reverse the sign. And we'll write that down when we get to it, probably in a couple problems here. But other than that, solving inequalities is just like solving equations. So on this one, I would add 7 to both sides and get x is less than -5. Okay, so I have it solved. Now most likely the book will ask you, or I will ask you, to write the solution or graph it on a number line and write the answer in interval notation just like we were doing earlier. So x less than -5 on a number line would look like this. Less than -5, strictly less, so on a parenthesis like that. And in our interval notation, that would be -∞ up to -5, parenthesis, parenthesis. And I've represented the solution in 3 different ways there. Here's another one. 14 plus 2m is less than or equal to 3m. Solving the inequality, I'm going to subtract 2m from both sides. 14 less than or equal to 1m. Now normally we want the variable on the left side, so I can just flip everything around, and this would be the same as m is greater than or equal to 14. Notice if you read this backwards, it means the same thing. M greater than or equal to 14. And that's what I have written right here. Greater than or equal to 14 on a number line would look something like this. greater than or equal to 14. We are including the 14, and so we want a bracket here. In our interval notation, that would be bracket 14 to infinity. And we have the inequality solved. Here's another one. (2k minus 5 is greater than or equal to 1 plus k. Okay, the first thing that I would do is subtract k from both sides. Get 1k minus 5 greater than or equal to 1. Add 5 to both sides. And we get k is greater than or equal to 6. So my solutions are all the numbers greater than or equal to 6. On a number line, greater than or equal to 6 would be bracket at 6 to infinity. And in our interval notation, that would be bracket 6 to infinity, just like that. Okay. Let's look at this one now. Negative 2x is less than 6. Now, to solve this inequality for x, we have to divide both sides by negative 2. Now, as I mentioned just a few minutes ago, the one extra rule that we have in solving inequalities is this. Reverse the inequality symbol when multiplying or dividing both sides by a negative number. That's the one extra rule. So since in this problem I am dividing both sides by negative 2, I have to reverse the sign right here. Reverse that sign like that, and I now have x is greater than negative 3. Probably the most common error the students make is forgetting when to switch that sign when solving these inequalities, so be very careful. That's our solution. On a number line, it would be greater than negative 3, so that would be shading everything to the right of negative 3, parenthesis. And in our interval notation, that would be parenthesis negative 3 to infinity. Okay, here's another one. Negative 3, x plus 4, plus 2 greater than or equal to 7 minus x. First thing I would do to solve this inequality is distribute the negative 3. Negative 3x minus 12 plus 2 greater than or equal to 7 minus x. Combine my like terms here. I got a negative 12 and a positive 2. That's negative 3x minus 10 greater than or equal to 7 minus x. Add x to both sides. Negative 2x minus 10 greater than or equal to 7. Add 10 to both sides. Negative 2x greater than or equal to 17. And now we have to divide both sides by negative 2, so I'm going to have to reverse the sign. And I get x is less than or equal to, well, I'll leave it as negative 17 over 2, like that. And what is negative 17 over 2? It's negative 8.5, I believe. Negative 8.5. So on a number line, we would shade everything less than or equal to negative 8.5, which would be right about here. And we are not including, oh no, we are including, because of the little equality here, we are including that number, so I want a bracket there at negative 8.5. Interval notation, over on this end, we're out at negative infinity to negative 17 over 2, parenthesis, and bracket. There's our answer in interval notation. Okay, let's try another. Negative 2/3 x minus 3 minus 1/2 less than 1/2 times 5 minus x. Now we got fractions all over the place here, and so just like with solving an equation, I want to eliminate all the fractions first so I don't have to deal with them anymore. So we multiply both sides by the common denominator, which in this case would be a 6. So I'm going to multiply this side by 6, and I'm going to multiply this side by a 6. Everything's multiplied by 6. Now 6 times this negative 2/3 is a negative 4. Oops, let me change my color here. So this becomes negative 4x minus 3. This part right here turns into that. The 6 must also be distributed over here to this minus 1/2. And 6 times the negative 1/2 is a negative 3. And over here, we got 6 times 1/2. That's a 3. 5 minus x. So that's what we end up with if we multiply both sides by the common denominator. Next step is to distribute the negative 4 and the 3 to get rid of all the parentheses. So we've got negative 4x plus a 12 here. On this side, we've got 15 minus 3x. Let's combine those numbers there. It's negative 4x plus 9 less than 15 minus 3x. Next step, let's add 3x to both sides, like that. Let me fix that mistake there. Plus 3x. So that's negative 1x plus 9 less than 15. Subtract 9. Negative 1x less than 6. And now finally, to solve for x, we have to divide both sides by a negative 1. I just divided both sides by a negative number, so I have to reverse the sign. And so I end up with x is greater than negative 6. So there's my solution as an inequality. On a number line, that would be everything greater than negative 6, just like that. We are not including negative 6, so I want a parenthesis there instead of a bracket. And in our interval notation, that would be parenthesis negative 6 to infinity, parenthesis. Okay. Now let's look at, let me back up here, what's called a double inequality. X plus 2 is between 3 and 8. The goal for these double inequalities is to have x by itself in the center. And so what I'm going to do is I'm going to subtract 2 from all 3 parts. Now what I'm doing is I'm solving 2 inequalities at the same time. So in the center I have x, and on this side I've got 3 minus 2, that's a 1, and over here I've got a 6. Fix that one there. And I have x by itself in the center, and that means I've solved the double inequality. X is between 1 and 6. On a number line, that means I shade everything between 1 and 6. It's like that. Now, we're not including the 1 and the 6, so I need parentheses. Just like that. And in our interval notation, that answer would be 1 to 6 with parentheses. Let's try another one here. -2 less than or equal to -3k minus 1 less than or equal to 5. All right. First thing I'm going to do is I'm going to add 1 to all three parts, which gives me -1 less than or equal to -3k less than or equal to 6. The next thing I have to do to get k by itself in the center is divide everything by -3. Just like that. And I just divided everything by a negative number, both sides, so I have to reverse the signs, as you recall. So these signs must now be reversed. And we end up with a positive 1/3 here and a -2 there. Now, we always like double inequalities, the symbols to be opening to the right side. And these have been reversed. So I'm going to write everything backwards. This is the same as putting the -2 over here and the 1/3 here and the k there, and flip these signs back. This says the same thing, that k is between -2 and 1/3. You always want to write this so that the larger number is on this side. It's the larger number, and this is the smaller number. And the inequality symbols must always open up to the larger number. Okay, that's our answer as a double inequality. On the number line, of course, you would shade between -2 and 1/3, wherever the 1/3 was, like that. And we want brackets there. And in our interval notation, that would be bracket -2 to 1/3 bracket. So there's my solutions. Okay, next. A rental company charges $15 to rent a chainsaw plus $2 per hour. You can spend no more than $35. What is the maximum amount of time you can use the chainsaw? All right, word problem here. So let's let x equal the time that you are renting the saw. So you got to pay $15 to rent the saw, plus $2 for every hour. And since we're saying that this is in hours here, since you're renting it for X number of hours, you're going to have to pay $2 times X. So this right here is the cost of renting the chainsaw. You can spend no more than $35. So no more than 35 means your cost has to be less than or equal to. So no more means less than or equal to 35. So that's the inequality we need to solve. So just like all the other ones before, I'll solve it. I'll subtract 15 from both sides. Let me fix that mistake there. I get 2x is less than or equal to 20. Divide both sides by 2. And I get x is, I don't have to switch the sign here, I didn't divide by negative. X is less than or equal to 10. So the maximum amount of time you can use the chainsaw, this tells me that this means 10 hours or less time. That way you'll spend no more than $35. So the maximum amount of time that he can, or that we can use this chainsaw would be 10 hours. At 10 hours, the cost would be $35. Another word problem here. You score 88, 86, and 90 on 3 tests. What score do you need on the 4th test to have an average of at least 90? So let's let x equal our score on the 4th test. So if we average all 4 of our test scores, we've got to take 88 plus 86 plus 90 plus whatever we got on the 4th test, x. And since that's 4 tests, we've got to divide by 4. So this represents the average of our 4 tests. We want to have an average of at least 90. At least means it has to be greater than or equal to 90. At least 90. This is the inequality that I have to solve. First thing that I should do here is just tally these numbers, 3 numbers right there. Those 3 numbers add up to 264. Like that. Multiply both sides by 4. Get rid of the fraction. Times 4. Times 4. 4's are gone now. And we get 264 plus x is greater than or equal to 360. And now subtract 264 from both sides. And we get x is greater than or equal to 96. And so the answer is, to have an average of at least 90, you need to score 96 or more. It's got to be 96 or greater to have our average above 90 or equal to 90. Okay, just a couple other quick things here that I forgot to mention that I'll just throw in. Suppose we shade the entire number line. Everything shaded all the way from negative infinity out here all the way to positive infinity there. Remember, you always put parentheses around infinity symbols, never brackets there. And so this represents all real numbers. All real numbers. Negative infinity to positive infinity means all real numbers. And I believe that we did not see one like this, so let me just throw one in. Negative 2/3 x plus 1 is greater than 5. There's a couple options. To solve this inequality, I could first multiply everything by 3, which would be fine. Or I could do it this way. Let me show you this option. I could subtract 1 first and get negative 2/3 x greater than 4. Now I need to get rid of the negative 2/3 multiplied to the x, so I can multiply by the reciprocal of the fraction. That's one way to get rid of that fraction. The reciprocal of negative 2/3 is a negative 3/2. So I multiply both sides of the inequality by negative 3/2, like that. But remember our rule, if I either multiply or divide both sides of an inequality by a negative number, I must reverse the symbol. So I got to remember to reverse the symbol here. This side works out to just be 1x. And over here, if I carefully multiply those numbers together, that's a negative 12 divided by 2, negative 6. And so I have my answer. X is less than negative 6, which on a number line, I would shade everything less than negative 6. Is that a bracket or a parenthesis there? That would be a parenthesis. And in our interval notation, this represents all the numbers from negative infinity up to negative 6. And there's our lesson on solving linear inequalities.